Hi, everyone. Today we're going to be presenting our research on the economic impacts of extreme heat, a case study from communities in Los Angeles County. I'm Griffen Wolfe.
Hi, I'm new Chanaporn Tohsuwanwanich.
I'm Kathryn Maffeo.
Hi, I'm Tatiana Flores.
I'm Paulina Fernández.
And I'm Helen Heath.
So our research is focused on extreme heat as it has become more frequent in recent years, negatively impacting urban areas' economic and public health. With that, existing literature tends to target economic impacts or public health as separate sectors, severely limiting the examination of the interdisciplinary effects of extreme urban heat. More specifically, urban heat further stratifies economic inequity, fueling a cycle of social vulnerability and limiting the upward mobility of these communities. Thus, we employ a framework for economic capacity in which we aim for our research to highlight the quality of life, skills, and resources of urban communities in Los Angeles County and how they're impacted by instances of urban heat.
Many scholars have studied how heat impacts communities, but not many touch on how it affects economic capacity. Existing literature on our dependent variables, including income, employment, housing, insurance, and transportation, have long been included in economic literature. Studies consistently reveal how fluctuations in these variables affect entire economies, influencing consumer spending, economic trajectories, and household wealth. Incorporating control variables like education, transportation access, green spaces, and demographics allows us to contextualize these effects within broader socioeconomic frameworks. Literature has shown that these variables play roles in productivity and overall economic advancement, accessing employment opportunities and maintaining economic stability, healthcare costs, and wealth gaps, which exacerbate economic insecurity and inhibit equitable economic progress. Our interdisciplinary approach enhances our understanding of heat's economic ramifications as we expand upon existing knowledge by examining how heat, an often overlooked environmental factor, affects economic capacity. By analyzing how extreme heat events impact labor productivity, housing, and healthcare expenditures, we shed light on a critical yet underexplored aspect of economic resilience.
Thus, our research question is, what effects, if any, did extreme heat have on economic capacity in Los Angeles County from 2013 to 2019?
For this research, we employed a quantitative analysis to show the relationship between extreme heat and other variables. We employed two different analyses, which is the statistics and the GIS, which is spatial analysis. For statistics, we used to prove the strength and direction of the relationship between independent and dependent variables while controlling for impacts from other control variables. And we acquired most of the data from American Community Surveys from the US Census Bureau. We did the data exploration and management. We also explored the relationship between independent and dependent variables through the scatter plots and linear regression. And we conduct the multi-regression analysis to see the relationships of these variables in addition to the control variables.
For the GIS analysis, we employed geospatial tools within the applications of Google Earth Engine and ArcGIS Pro to visually represent the relationship between our variables. We acquired publicly available data such as the US Census Bureau and others to create our maps. For the temperature trend map, we performed linear regression analysis on GEE using MODIS data, for it is most beneficial when trying to quantify and visualize the changes in temperature throughout the years. We then export the data from GEE as a raster onto ARC, where we stretch the raster to account for outliers by doing mean, plus, and minus the standard deviation. We then use the zonal statistics tool to find the median of all the values of the pixels within a tract. For our other maps, we cleaned, downloaded, and uploaded data as a CSV file onto ArcGIS Pro, where we use the table join tool and change the symbology to visually represent our findings. This map showcases the average age and census tract areas with no vehicle from the years 2013 to 2019. The solid colors depict the different age groups, whereas the stripes indicates the percentage of no vehicles within a tract. In the lower center of the county, a region where there are a high percentage of young people, there are 12 to 21% that have no vehicle. In some areas, the numbers increase to 21 to 35%. Other areas where there is a high concentration of elderly, 35 to 86% have no vehicles. All in all, these variables also suggest socioeconomic disparity within Los Angeles County.
So using the zonal statistics tool, we find that 64% of Los Angeles County tracts had a median temperature change greater than 0 degrees Fahrenheit, as seen on the histogram side, implying an increasing temperature trend for more than half of the county of Los Angeles. And on this slide, you can see the areas that face increasing temperature trends in more central, eastern, and the valley in Los Angeles County. This was the basis for our independent variable, as we are able to see the impacts that heat has on economic capacity while taking socio-demographic information into consideration as well.
So running ordinary least squares regressions of our dependent variables against the temperature trends from 2013 to 2019, we can see statistically significant and positive relationships between temperature increases and the percentage of uninsured population within communities, the share of population working in heat-affected occupations, as well as the share of households spending greater than or equal to 30% of their income on rent. Each of these coefficients represents a percentage point increase in each of the dependent variables with respect to a 1 degree increase in temperature year over year. We can also see a negative relationship between temperature increases and median household income of communities. However, when we control for age, education, and the percentage of households with no vehicle in communities, we can see that all of the results weaken substantially. However, that our model captures the majority of what's going on in terms of the relationship between temperature trend and each of the dependent variables. So this indicates that our control variables do play a significant confounding effect on this relationship. Delving into the visualization of this data a bit, we can see here the positive relationship between communities which experience year-over-year increases in temperature are also those that have a higher share of uninsured population. We can also see that those same communities that saw increases in temperature over the time period also had higher shares of their population working in heat-affected occupations. Going into median income, we can see that those communities which experience temperature increases were also tended to be lower income, and they also tended to be more heavily cost burdened with respect to housing costs, spending greater than or equal to 30% of their incomes on rent.
Based on our analysis, it shows that there's positive change of temperature over years in Los Angeles counties, which results in significant changes of economic capacity, limiting the households for pursuing economic opportunities and worsening socioeconomic conditions. From the statistical analysis, it shows that every single Fahrenheit that increase, there's the decrease in median household income, an increase in housing cost burden, an increase in share of population working in heat-affected populations. From the spatial analysis, it shows that there's the socio-demographic status plays an important role in shaping people's experience on extreme heat and climate conditions. Thus, there should be policies that mitigate and adapt the city to be more resilient to the changing environment, which stems from urban heat island and global climate change, and should help to minimize the impacts of extreme heat on people and the economy.
Lastly, we'd like to thank IUSSC, our advisor Ruth, Dr. Bo, Dr. Sahar, Juan, and all other reviewers for their support.
And thank you so much for listening.